This screencast is going to talk about solving percent problems. So before we've looked at finding the percent of a certain number, and now we're going to look at some parts that might be missing. So if you take a look at the screen, this was also in your solving percent problems packet, talking about the word proportion and percent proportion. So once again, a proportion is an equation that shows that two ratios are equivalent. So proportion just means that they are equal to one another. So it's an idea of equivalent ratios. And in a percent proportion, one ratio compares a part to the whole, and the other ratio is the equivalent percent written as a fraction with a denominator of 100. So for example, if we look at 10% of 40. We know that 10% becomes 10 over 100. And instead of doing 10% of and changing of to a multiplication sign, we can make it an equal sign. And then we would write 40 over 1. If we look at this, we know that we're multiplying by 4. So we'd have to multiply by 4 here. 100 times 4 would be 400. And this would show that your proportions are equivalent. What we're going to look at today is some examples where we are actually looking at the opposite of this, and we are going to look at a number being a percent of an unknown. So for example, 6 is 12% of what number? So basically what we would do is we would write 6 as a fraction, but we don't know what the denominator of the 6 fraction is. We do know that the word is means our equal sign, and then that 12% can be written as 12 over 100. So if you think about it this way, once again, we are using that idea of equivalence, so equivalent ratios, equivalent percents, and we are looking at 12 to 6. How would we go from 12 to 6? We would divide by 2. So then how would we go and figure out this unknown? We would have to divide by 2. So this would end up becoming 50. So that tells us that 6 is 12% of 50. So if we take a look at this particular slide, this is looking at how do you compare part and whole. So if you take a look at the fraction part of this, this is looking at 2/5 is part of a whole. What do you call the part? We call the part the numerator. That's your top of your fraction. And what do we call the whole? The whole is the denominator or the bottom. So denominator is the bottom of a fraction. Ratios, we should all be familiar with ratios. So using the information in the first ratio, fill in the others. So 2 fraction 5, so 2 to 5 would then be 2 to 5 and 2 colon 5. All of these are then equal to one another. Finally, looking at our percents, so we're showing that all of these are actually interchanged, can be interchanged, interchangeable. They are kind of the same idea. So 2/5, if we look from 5 to 100, we would multiply by 20, multiply by 20, 2 times 20 is 40. So 40% of 5 is 2. Once again, using the percent proportion, it says the diagram uses a percent proportion to show that 75% of 32 is 24. So once again, if we take a look, we're writing our percent as 75 out of 100, and then we're looking at 24 is the part, and 32 is our whole. So if we take a look at this example on this slide, it says 15 is 30% of what number? So once again, we're going to take a look at 15. 15 is the part, so that's why they're putting it down here. We don't know what the whole is. We do know that 30% can be written as a fraction of 30 over 100. Now we're going to think about how do I go from 30 to 15? Well, I would divide by 2. So once again, I'd have to divide 100 by 2, and that would give me an answer of 50. So that means that 15 is 30% of 50. So 30% of 50 is 15. Let's take a look at this example. We're going to fill in our blanks. So we want to go straight down. 225 is our part. We don't know what our whole is. 75 out of 100. Now we want to think about how do we go from 75 to 225. So if you take a look at the screen, you can see that I did my multiplication problem. So 75 times 3 gets me to 225. So then I would do 100 times 3, which would get me to 300. So if I jump down here, I know that 225 would be out of 300. So 225 is 75% of 300. So that's my final answer. Let's take a look at this example. This example says that Kara is on her school basketball team. She has completed 9 out of 12 free throw shots successfully. Write the ratio as a percent and as a fraction in simplest form. So 9 out of 12. The word out of means fraction. So 9 over 12. I want to write this as a percent and as a fraction. So this is a fraction in simplest form. So I need to change this so I can divide by 3. Divide by 3, I would get 3/4. And then if we know anything about 3/4, this is a common fraction, so we should know the percent. If you're not sure, you can multiply by 25, because that would get you to your answer that has a denominator of 100, so 3 times 25 is 75, which we should all know. So our final answer would end up being 75%, and 3/4 would be our simplest form fraction. Let's take a look at a few more examples using the idea of a percent proportion. So if we start with letter A, we know that we have 30 is equal to 50 over 100. Then we're trying to figure out what goes down here in the bottom. So we have to think about how would we go from 30 or from 50 to 30. And then we'd have to do the same thing to 100. So in order to figure this out, we actually have to work backwards. So we need to think about 50 divided by 30. So I'm going to actually write this as a fraction. So if I divide by 10, that gets me to 5/3, which then gets me to 1 1/3. So that would tell me that I would have to multiply, 1 2/3. So that would tell me that I would have to divide by 1 2/3. So if I look at 1 2/3, I would know that that's actually equal to 1.6 repeating. So if I divide 100 by 1.6 repeating, and I did type this in on a calculator, I would actually get 59.9 repeating. 59.9 repeating. So the other thing that I could do, because I have 50 over 100, is I could think about really the fact that this is 1/2 and change that equal to 30 over something. Well, to go from 1 to 30, I would multiply by 3, and then 2 times 30 would get me to 60. So notice that my answers are pretty close, that I have 59.9 repeating, which really would round up to 60. Let's go ahead and take a look at part B. 60 is 20% of what number? So I'm going to have 60 over something equals 20 over 100. I want to think about how I would go from 20 to 60. I would multiply by 3. So if I multiply 100 times 3, I would end up getting 300. So 60 is 20% of 300. So sometimes you'll get some harder ones like letter A, and then sometimes you'll get some easier ones like letter B. Let's take a look at our final example. So go ahead and read the word problem on the screen. And this says that Peyton spent 60% of her money to buy a new television. If the television cost $300, how much money did she have? How much money did she start with? So once again, it's $300 out of whatever her starting amount was is equal to 60 over 100. So I need to think about how would I go from 60 to 300? Well, I know that 6 times 5 is 30, so 60 times 5 would get us to 300. So then I have to look at 100, do the same thing because these are technically proportions or equivalent ratios. So 100 times 5 would then be 500. So she started out with $500. What I would like you to do is I want you to try and solve each of these problems. So D, 75 is 15% of what number? E, 9 is 36% of what number? F, 7 is 70% of what number? And G, 7 is 35% of what number? So if you take a look at the screen, you'll see all the answers circled in yellow on the screen. So for letter D, you should have gotten 500. Letter E, you should have gotten 25. F, 10. And G, 20. One final question that I want to take a look at, it says before 1982, pennies were 95% zinc and 5% copper. If 100 pennies minted in 1980 have an approximate mass of 15 grams of copper, what is the total mass of 100 pennies? So we're trying to figure out, we have our percent of 5% copper, because it's 15 grams of copper. So we have 15 is our part. We're trying to figure out our total or our whole. We have 5% out of 100, so 5 out of 100. So how would I go from 5 to 15? I would multiply by 3, so I would need to multiply 100 times 3, and that would get me a final answer of 300 grams, and that would be my total mass, or my total weight would be 300 grams. So you're using percent proportions in order to help you figure out the missing total. So instead of saying 5% of 300, you're actually figuring out what that total is originally.